bit of pressure. It'll be posted right here along with all the other class recording videos that we've done. Today should be, I think, a little bit shorter day. There's not as much of the notes for us to go over. Some pretty simple concepts that we're going to nail down. And so at the end of the day, if you have any questions about either today's stuff or the stuff from Tuesday with the heating curve and the states of matter and stuff, I can go through some of that with you guys as well, if you're still a little bit confused about some of the stuff. All right, so today we are going to be getting into chemical and physical properties, different ways that we can kind of classify or describe matter. So remember, from Tuesday, matter is just the fun sciencey word for all of the stuff in the universe. In science, we decided that stuff doesn't really sound like a very formal term, so we call it matter. And so there are a couple different ways that we can describe or we can observe the matter that is out in the universe. We can describe its physical properties and physical changes, and then we can also describe the chemical properties and chemical changes of the matter. So today we're just going to kind of go through these one by one, talk about what they mean and what are some good examples of these things. So we're going to start off with our physical properties of matter. And the physical properties are probably some of the easiest things that we're going to talk about today. So a physical property is a characteristics of a substance or of a piece of matter that you can observe without changing its identity, meaning that when you are observing it, when you're measuring it, you're not changing it into something different. So the key word here is observed. So observations you can make with any of your five senses. As humans, we probably most commonly use our eyes to observe the world around you. So things that you can see about matter would be some of its physical properties, like how big or how small it is, what color it is, what sort of material that it's made out of. All of that would be physical properties, things that you can see about this matter. It could also be things that you feel, like is it really rough and bumpy, or is it smooth and flat? Is it hot? Is it cold? Or even smell. Does it give off like a particular smell? Or in the case of food, you can even have taste as a physical property. So this lemon tastes really sour, but this cookie tastes really sweet, and this coffee is really bitter. All of those are physical properties, things that we can observe with one of our five senses about a piece of matter, about something that we are looking at. So we can use physical properties to kind of group things into categories to separate out different mixtures. If we have a whole bunch of matter mixed together, we can kind of sort it by its physical properties. So like I said, things like color and size, things we can see about the matter. The state, so we talked about the states yesterday, the solids, liquids, and gases. And so what state that the matter is in, that is its physical property. Are we looking at solid water in the form of ice, or are we looking at liquid water in the form of water like a puddle? We can also consider physical properties, things that we can measure about a substance. So its mass, how heavy it is, its density, the kind of comparison of how heavy it is versus how much space it takes up. These are things that we can measure about the matter, and a measurement is a type of observation. So they are physical properties of matter. So anything that we can see or observe when looking at a piece of matter is a physical property. So, for example, we can measure water freezing at 0 degrees Celsius. So that's a physical property. These chunks of metal over here, they're very smooth, they're hard, they're heavy, they're shiny. Those are all physical properties, right? They're all things that we can see when we observe these big chunks of metal. So its mass, how it feels, how it looks, all are physical properties. So this bottle over here is made out of plastic. And one of the physical properties of this particular type of plastic is that it is clear. It is see-through. You can look through this bottle, and if you like waved your hand on the other side of the bottle, you'd still be able to see it because of the clear plastic. Also, the plastic is very thin. It's very weak. You could squish it. You could crunch it down. You could make it bigger. So the fact that you could easily kind of break and bend it is also a physical property, right? That's something you can observe by kind of feeling and touching the plastic, is how thin it is. Like I said, observation does not have to just be limited to sight. It could also be things like smell or taste or sound even. So like if some fruit has been rotting on your kitchen counter for a couple weeks, A, gross, you should clean that up. But B, even if you were blindfolded, right? Even if somebody covered your eyes, if they handed you a piece of rotten fruit, you could smell it, you could taste it, and you would know like, oh, this is not good. Something is very, very wrong with this peach or this apple or whatever this used to be. It is really gross and rotten now. So the smell and the taste of the fruit are physical properties that indicate to us, people who would like to eat it, that in fact it is bad, it is rotten. It's full of bacteria and mold and all sorts of little nasty things. So, physical properties, things that we can observe or measure, whether that's things that we can see, things that we can smell or taste, things that we can feel, things that we can measure, like weight or density or temperature. These are all physical properties of that matter. Now, what happens if we take the matter that we're looking at and kind of like our plastic bottle here, we squeeze it or we stretch it or we break it up into pieces? It's the same matter that was there before, right? Like this metal used to be one big piece of metal, but then it fell maybe, or somebody hit it with something and it broke up into a couple smaller pieces. When that happens to matter, we call that a physical change. So the matter has changed. It doesn't look exactly like it used to, but the identity of the substance, what it is, did not change, right? If you squish that bottle down or flattened it out, it would still be a plastic bottle. It would just be a flat plastic bottle. Or that metal that somebody hit with a hammer and it chipped and broke, all those pieces are still the same metal. They didn't change into something new. It just got into smaller pieces. So that is the big thing to remember with this physical change here, is that we're not making something new, we're just changing how our matter looks. So the properties of it are going to remain the same, right? We started off with a big piece of metal, now we have smaller pieces of metal. We started off with a nice round plastic water bottle, now we have a flat plastic water bottle. But it's still made out of metal, it's still made out of plastic, it just looks different than we did before. We changed the form of our matter. So shredding things is a pretty common physical change, right? Like if you take a piece of paper and tear it up into confetti, all those tiny little pieces are still paper. They're still made out of the same stuff. They're just in a different form. Grinding is another example. So if you're like sharpening a knife or like a big axe or something, like you see like the old school sharpening wheels and like movies with like the people have the axe and they're putting it against the wheel and all the sparks are coming up. all the tiny little pieces that are coming off to make it sharp, and the axe itself are still the same metal that it started off with, right? They didn't change the metal and the axe or the sword or whatever they're using. They just shaped it a little bit differently. They changed its form slightly, in this case in a way to make it sharper. Melting, or going through any phase change really, is another good example of a physical change. So like when we take our ice and we let it sit out on the counter and it melts into water, because remember, melting is when we go from a solid to a liquid, like we talked about on Tuesday. That ice melts and now it's a puddle on the floor or on your counter, but it's still water, right? It didn't turn into some new chemical, some new substance when I melted. It just went from solid water to liquid water. Same thing if you're boiling it. So if you crank the heat up and you see all that water vapor coming off, those are still particles of water that are going up into the air. They're now just much smaller and further apart than they used to be when they were in the water in your bowl. Dissolving is another cool example of a physical change. So like if you have some tea and you want to turn it into sweet tea, you got to put a lot of sugar in it, right? Well, when you stir it up and that sugar disappears, that sugar is still there because when you drink that tea, it's going to taste sweet, right? You can taste the sugar in your drink. However, the sugar molecules just went from big crystals that we could see to tiny little sugar molecules that we can't see anymore. They're still floating around in our drink, but they just changed size. They went from big crystals to tiny particles. So physical change is all about staying the same, maybe getting bigger or smaller, but not turning into something new, staying the same thing that it was before. So some visual kind of representations of what we were just talking about, and a lot of this stuff I gave kind of examples for. So this wood chipper right here, we're putting in big branches into kind of this dangerous metal shredding part. And then this tiny little sawdust stuff is shooting out the other side. While this is a pretty drastic change of form, right? We're going from a nice big tree branch to tiny little particles of wood. It's still only a physical change because we're starting off as wood. These little pieces are still little pieces of wood. They're just much, much smaller than it was before. So we're starting off with wood. We're ending up with wood. We're just changing how big and how close together the pieces are. So that is a physical change. We start and end with the same stuff. Like I said before, when you're boiling some water, I was going through this today because I literally made myself some pasta for lunch before I came to school. So once that water starts boiling, that steam starts coming off the top. This is water vapor. So this is water in a gas form. We have liquid water going to gas water by boiling or vaporizing, but it's still the same substance, right? It's still water. We've got water in our pot right here. We've got water that's floating through the air as a gas. It's a physical change because it didn't turn into anything new, anything different. It's water in here and it's water out here. We just changed kind of how close together those particles were. They used to be kind of close in a liquid. And then when we boiled it, we separated those far apart and turned it into a gas. And then finally, if you ever add like sugar or salt to a liquid, like I don't know if your guys' mom ever made you do this when you were a kid, but when I was younger and I had like a sore throat or something, my mom would make us gargle salt water because it was supposed to like help heal the inside of your throat. And so she'd get a big warm glass of water and dump a bunch of salt in and swirl it around. And the salt crystals disappeared. Not because the salt got changed and got morphed into something different, just because the salt went from being in big crystals to tiny little salt particles floating in the water. Believe me, that salt was still there, so I had to gargle it. It was gross, It tasted like you got a mouthful of seawater. It was nasty. I would not recommend doing it, even if your throat doesn't feel so good. Just take like a cough drop or something. This is kind of like a more old school method, and it was gross. Did not like it. But again, it's a physical change because the salt crystals are still salt even when they get dissolved. So we have salt up here, we have salt down here. It just goes from being in a big crystal that we can see down to tiny microscopic particles floating around in the water. So physical changes are all about starting and ending at the same substance. You've just maybe changed how it looks a little bit. You shredded it up, you've turned it into a gas, you've dissolved it in some water. You haven't changed what substance you have just changed how it looks. You've changed the form of your substance. You made it smaller, you made it bigger, you made it seemingly disappear, but it's still the same matter. It's still the same substance. All right, any questions so far about physical properties or physical changes?
No.
No, we're good.
All right, cool. So, like I was saying, in a physical change, we have the same substance at the start and at the end. We just changed how it looks a little bit. What about if you do have a change in substance? What if you start off with one set of substances, one set of matter, and then it gets turned into something new, something different? That is called a chemical change. So a chemical change happens when you change the identity of the substance. You turn it into something new, something different, something that was not there before. So this new substance, it's a different matter, so it has different properties and maybe some different physical properties than the original substance. There are some signs that can happen that tell you maybe that a chemical change is going on. So if the color of your chemical changes, and I don't mean like you add some purple Kool-Aid into the water and swirl it around and now the water is purple. That's not the kind of color change that I'm talking about. I'm talking about if you like combine two different clear chemicals and then all of a sudden they turn blue. That would be a sign that, oh, something has changed. We have a new substance that wasn't there before. Also, very commonly, a gas or a solid gets formed and released. So if you're mixing two different things together and then all of a sudden they start like bubbling and fizzing, like if you've ever seen the classic combination of vinegar and baking soda, that's what the like kids at the science fair a lot of times will use to make like the big volcano go. And that's because when vinegar and baking soda combine, there's a chemical change that happens that produces a new substance that's a gas that wasn't there before. And so now that gas is all popping off and fizzing out of the substance. Also, if light or heat is being released, like for example, in the case of fire, so if you light some wood or some matches or something on fire, you can see the light of the flames and you feel the heat when you put your hands close to it. That's because there's a chemical change happening between the match head or the wood and the air around it. And that chemical change is causing all of this heat and light to be given off. So we're starting off with one set of substances and ending up with something new, something different. So burning, kind of like I was just saying, is a really good example of a chemical change. We're taking some sticks or some logs and they start off as wood, right? But then we add some heat, we add some oxygen, it starts burning, all this light and heat is given off, and there's smoke going up into the air, and there's ash being left on the ground. And that smoke and ash are different chemicals than the log that started off the whole process. So because we're ending with different chemicals, new substances than we started with, that's a sign of a chemical change. Rusting is also a good example of a chemical change. So if you ever left like a bike outside for multiple seasons, and you'll see on the chain or the wheels will get a little bit rusty, you'll see that kind of brown flaky stuff start to appear. That's happening because of a chemical change between the oxygen and the iron in the metal. So we've got a color change because the metal used to be nice and bright and shiny and probably kind of silvery, and now it turned into this brown flaky stuff. That brown flaky stuff is called iron oxide, and it's a different chemical than the iron that was there originally. A chemical change has happened. So again, chemical changes are all about going through some sort of chemical reaction to produce a new substance, a different substance than what we had before. So burning, again, giving off lots of light and heat, which are some signs that a chemical change is going on. And we're giving off lots of smoke going up into the air. And then we're going to have this kind of leftover ashy stuff. Same with the combustion in your car, right? So when you burn fuel inside of a car's engine, the burning of that fuel changes that gasoline into water and carbon dioxide, which then come out the back of your exhaust pipe. So we use the energy from the burning to like power the piston that makes the car go. But it starts off as gasoline and ends up as different substances. So a very important chemical change to us humans. Rusting, like I said, we have the silver iron is reacting with the oxygen in the air around it to produce this brown, flaky iron oxide, which again is a different chemical than the silver iron that was there before. And then a really good example of some rapid gas formation is if you ever have like some heartburn or something and you take an old school Alka-Seltzer tablet, when you drop that little tablet in the water, all this fizzing and bubbling starts to happen right away. And that's because the tablet and the water are chemically reacting with one another to produce this gas that's being bubbled and fizzed up, so that when you drink the water, you get the medicine that was inside of the tablet. And so all this gas being given off is due to a chemical reaction and a chemical change between the water and the tablet, right? So the gas wasn't there before, it's only there now because this tablet is chemically changing into new substances, one of which is a gas. And so then that gas is going to want to come out of the water and kind of fizz up to the top of the cup. So chemical changes, new substances being formed, gas is bubbling and fizzing off, things are burning and lighting on fire or combusting in some way. There's some sort of explosion that's happening, or the chemicals are just reacting over time and rusting or changing or whatever it is that they're doing. The whole idea is that we're changing some original chemicals, some original set of things into something new, something different. So the opposite of the physical changes, because the physical changes, we started and ended with the same stuff. It just looked a little bit different and had a different form. And chemical changes, we are not starting and ending with the same stuff. Our ending stuff is different from our starting stuff. All right, so finally, depending on what sort of chemical we're looking at, whether it's an Alka-Seltzer tablet, iron chain, or some wooden logs, these chemicals are all likely to go through specific types of chemical changes. So how likely it is for a substance to go through a specific chemical change is called its chemical properties. So a chemical property of a substance is how likely is it to undergo a specific type of chemical change. So how likely is it to catch on fire? How likely is it to turn into a gas and go up into the air? How likely is it to react with any other chemicals that it comes in contact with it? How likely is it to rust if you leave it out in the air over a long period of time? Those would be chemical properties of a substance. So, for example, things like wood and gasoline and propane, their main chemical property is that they are very flammable. Very easy to light those things on fire. On the flip side, my metal cup right here is very non-flammable. It is very, very difficult to light this guy on fire. So wood and gasoline have a high flammability, a high chance of catching on fire. So that's one of their chemical properties. Chemical properties of metals, like this cup right here, is that they are very unlikely to light on fire. Same thing with reactivity, which is just how likely is this chemical going to react with stuff in the air or stuff that it comes into contact with. Some chemicals are very reactive and they have to be kept in secure containers because if they touch a little bit of air or a little bit of water, they'll explode, essentially. Whereas other chemicals are extremely unreactive. They won't have any sort of reaction no matter what situation you put them in. So whatever chemical change that you're talking about, the chemical properties of a substance are how likely is it to go through that chemical change? Is it very likely that this thing will catch on fire or not? Is this a very reactive chemical or is it very non-reactive? Those are the chemical properties of substances. So they're not really things, unlike the physical properties, these aren't really things that we can observe or like measure with a measuring stick, but they are things that we have determined by doing experiments with different sorts of substances over time. Right, and I think that's the last new thing that I wanted to talk about. So just to kind of review everything all together, we have our physical properties, which are things that we can observe about a substance, like color, size, weight, length, measurements, density, taste, smell, temperature. All those different things are physical properties of that substance, things that we can physically observe and measure. If we change how that substance looks, if we tear it up into pieces or stick a whole bunch of pieces together, but it's still the same substance, then it's gone through a physical change. So we've changed sort of the physical appearance of it, but it's still the same substance underneath. If, on the other hand, we do something to our substance and cause it to change into a new set of chemicals, then it's now just gone through a chemical change. So we end up with something that's different than the chemicals that we started off with. And then finally, the ability of a substance to go through a chemical change is called its chemical properties. So is a substance very likely to catch on fire or go through a reaction? Or is it very stable? Is it very unlikely to do any of those things? All right. Any questions about our physical or chemical or properties or changes? Any today so far?
No, sir.
All right, awesome. Thanks, Crystal. So, For the homework that you guys are going to do kind of relating to these different topics, I split it up into two pieces, one for today and one for tomorrow. So today's assignment, which has already been posted, gives you a little bit quick reminder of kind of our physical properties, or just properties in general. So a little thing about physical properties and a little thing about chemical properties. So there's kind of two parts. The short first part is asking about if you have like a piece of wood or like a big log in front of you, what are three physical properties that you could use to describe that log? And then what is a chemical property that you think that log would have? That would be sort of the first part. And then the next part is a series of 10 questions where I give you a kind of random property about a certain material like iron or glass or hydrochloric acid. And it's up to you to tell me, is this property that I'm describing a chemical property or a physical property? So on the Google Doc version, you'll just go through and for each question, indicate if you think that it's a chemical property or a physical property, whichever one you think best. If you do the Google Docs version, then there's just little blanks next to the properties where you're going to type in a C or a P for chemical or physical. It's a relatively short one for today, just 10 questions plus those couple first ones about the piece of wood. Then the assignment for tomorrow, very similar. Only now, instead of talking about chemical and physical properties, we're talking about chemical and physical changes. So again, a little short reminder of what is a chemical and a physical change. And then a slightly longer list. I think there's 18. Yeah. 18 changes that are going to be described about things like ice or oxygen and hydrogen or salt water. And it goes through some sort of change, and it's going to be your guys' job to tell me, is that a chemical change or a physical change that I have just described down here? So pretty much the exact same setup as the assignment from today, but talking about chemical and physical changes instead of properties. All right, so that will be your daily assignment for Friday, those 18 questions. All right, so does anybody have any final questions about the notes, the physical chemical properties, or the assignment for today, or the assignment for tomorrow?
No.
Alrighty, doesn't sound like it.